Hello everyone, in this video we will be learning about solid principles. So these are a set of principles that we follow when writing code to make your code extendable, maintainable and easily testable. So let's just dive right in. So solid principles. Solid is first of all an acronym for SOLID, standing for each of these principles that you see here. So it's a set of 5 design principles that help you write cleaner, more easily extendable and testable code. So 5 design principles are, the first one is single responsibility principle, the second one open and closed principle, the third one Liskov substitution, fourth one interface segregation, and fifth one dependency inversion. I know I'm throwing a lot of words here. Even when I was a junior developer, I was so afraid of these names, believe me. Like especially this Liskov substitution and interface segregation. So let me break all of this down to you so that it's easy to understand for you. Now a common question arises, can I write code without following these solid principles? My answer would be yes, you can. But without solid, your code becomes rigid, difficult to extend, prone to bugs, harder to manage as it grows. So following solid helps avoid these issues, making your code base cleaner and more adaptable for future changes. Now enough chit chat, let's now move on to our first principle, which is single responsibility principle. Now this principle states that a class should have only one reason to change. It should be responsible for only one part of software's functionality, and it should have a single well-defined responsibility. Now, honestly, if you ask me, that definition can get confusing. And if you talk about this word responsibility, it can become a vague term. So let's try to understand this using an example now. So here we have created a class called as vehicle inside this vehicle.py file. Here we have 3 methods, the initialization, calculate insurance cost, and toJSON. The initialization looks pretty simple. It takes in make, model, and year as its parameters and sets it. The second one is the calculate insurance cost. Here it calculates the age, and if the age is greater than 5, it returns 1000, otherwise 500. Pretty simple, right? Now moving on to the third one, which is toJSON. This method basically returns a JSON object in this particular format. We have also created this main method here, which basically initializes a vehicle with Toyota Camry 2018 and then simply prints the insurance cost and toJSON. So let's just run this and then see the output. So as you can see, let me clear this out. Let me run this again. So as you can see, the insurance cost is $1,000. And the vehicle details in JSON look something like this. Looks perfect. Now if you see, we have violated single responsibility principle here. This class vehicle should have only one reason to change. And obviously we are not following that. We see that we are initializing and then we have insurance details here and then printing here. So we are obviously violating single responsibility principle. If you think this model is very unintuitive, so if we want to make changes regarding insurance or even formatting or printing here, we have to think about this class as vehicle, which feels unintuitive to me. So here we are violating single responsibility principle or SRP. Vehicle has more than one responsibility. Now even if you look at this calculate insurance cost method, we see that this method might depend on some other factors unrelated to vehicle. Let's say it depends on the address. In that case, all of this would have to be moved out, or we would have to add another parameter here called as address, which doesn't make sense to me. Here, as you see, we have added all of these methods inside this one single class called as vehicle. Now this is very incorrect because if you see in the main method, when we write main method, we don't write all of the stuff inside this main method, right? We have different methods which we call inside this main method. And similarly, what we have to do here is that we'll create different classes for different purposes, different responsibilities. So what to do now? So let's try to use single responsibility principle and then break this down into multiple classes. Now here I have separated all of those responsibilities into different classes. The first one being vehicle, where I have simply initialized it with make, model and year. There is another file or class called as object formatter. This has a method called as vehicle to JSON. It takes in as input vehicle and then returns the JSON output. Very similar to the previous one, but separated into a different class. Now we move on to the insurance calculator. This one also has a method called as calculate car insurance. It takes an input as vehicle and basically the same logic here. Now, after separating all of those, I'm testing it out in the main method. I'm importing all of those classes in here, as you can see. Now in the main class, I'm initializing all those three vehicle, insurance calculator and the formatter and simply printing it out. So let's just run this main method and see. So as you can see, it gave us the right output, car insurance as 1000 and vehicle details looks correct to me. Now we have understood the single responsibility principle until now. We have changed our code and we have created multiple classes like these and we have separated different classes. Now it's time to understand why are we even thinking about single responsibility principle? What would be the consequences if we don't follow this? Now, what happens if we don't follow single responsibility principle? So the first thing is that finding where to make the changes becomes very difficult. How so? So let's take an example of a really big repository or code base where there are hundreds of these files. Here we have vehicle.py, object formatter.python file, insurance calculator, but there could be hundreds of them. So if we do not have the single responsibility principle, we could have different methods in different places. So let's say in our earlier code, we had the printing code inside the vehicle.py. That didn't make sense. So if I think about making changes to the printing, I would have to find the vehicle file and then make changes. Do you feel how unintuitive that is? It's like, take an analogy where you have to find a comic book placed in library's physics section. You go to the library and go to the physics section to find the comic book, right? You have to go to the comic book section to find the comic book. That is what single responsibility principle is. So that gives us the first point, that is finding where to find changes becomes difficult if we do not follow it. That is maintainability is lost. Now the second point is we have to write repeated code if we don't follow single responsibility principle. So as you could see in the previous code, we had the printing logic inside the vehicle class. This whole printing or like the formatting, as you can say, was inside this vehicle class. So we can have different classes who want their JSON representation. So it's like a repeated code you have to write again and again for, let's say, vehicle.py, person.py, car.py. You'll have to go on for each and every class and then write those repeated code again and again for the formatting, this part. So if we follow our solid principles, we do not have to write that repeated code again and again. Now, before moving on to the third part, let's try to imagine a scenario. Let's say, let's look at this vehicle.py. Now, we have the formatting to JSON code here as well. We could have another file called as person.py. We could have another class called as car.py. All of those would have this formatting code there. And let's say somebody comes up and say, make changes to the printing or the formatting for all of those files. You will have to individually go into those files and make changes. That's not the case here. In this case, we just have to make changes to this file. That's it. So solid, if we do not follow solid, we need to do modification at different places when there are new changes. And don't even get me started on the unit test part. So if you look at all of those files, we make changes to vehicle.py, car.py, person.py. We'll have to make changes to the unit test as well. And that's a big hassle. So if you don't follow SRP, these are the 3 consequences that could happen. Now, after all of this discussion, I want you to remember these 2 thumb rules. The first one being, whenever you have a class, you need to add a method there. So you should add a method according to the class name. Now, what does that mean? Let's say I'm writing a class for vehicle. So I should think about, whenever I'm writing a method here, I will think directly about if it's related to vehicle or not. In our previous code, we were writing formatting to JSON method here as well, which was unrelated. So that's what we get from the first one. But there could be cases where we are writing a method which might seem related. So we were adding, let's say, the insurance part there in vehicle, which seemed to be closely related or somewhat related. I'm not talking about those cases, but if you obviously see that it's obviously incorrect to place the printing to JSON or formatting to JSON in vehicle.py, do not add that. So that's the first rule. But for those cases where you're confused, you should think about following the second rule. The second rule says, ask yourself this question: will this method be used by other classes too? If so, yes, the answer is yes, then you should think about moving it to a separate class. So in our case, we moved object formatter, we moved the JSON part to a different class called as object formatter, because it could be used by other classes. And similarly for insurance, there could be a home insurance as well, or some other kind of insurance. That is why we moved it to a separate class. Before moving forward, I would like to add one small detail here. There's a disclaimer on these rules that these rules are not 100% accurate, but it will give you a good idea, fair bit of idea on how to write code according to single responsibility principle. Hello everyone. So in today's video, we will be learning about open and close principle. This is the second principle from the solid, and it's a very interesting one. So let's just dive in. So in previous video, we learned about the solid principles, the basics of it, the 5 key design principles, and why should we learn these principles, what happens if we do not follow it, and single responsibility principle. We also learned about some thumb rules to follow. And in today's video, we'll learn about the open-close principle. Now, what is this open-close principle? What is the definition for it? The definition says that a class or module should be open for any kind of extension, but closed for modification. Now, this can get confusing. So in simple language, if we say, it is that when you want to add a new feature, you should think about creating new classes or modules rather than modifying the existing classes or modules. I know this is not very clear here, but let's try to understand this using our example. Now, just to recall, we had our vehicle.py file, that is the vehicle class here, some initialization. We had insurance calculator file with insurance calculator class and calculate car insurance method there. We had object formatter class, and we also had seen that this was working in the main file. Like we just run it again, so it works perfectly. So that was the overall summary, but we need to make some changes here. So I see that in the insurance calculator, we are passing it vehicle, and then the name of that method is calculate car insurance. That doesn't seem right. So let's just go ahead and then change things here. And let's try to run this again. And we have to make changes here as well. Okay, this works perfectly. Now let's say in this code, you want to add more types of vehicles. So in this vehicle, it could have car, truck, or any other type of vehicle. So let's just introduce different classes for those. So let's say I create a class called as car, Y, And let's just also create a truck.py. Now let's just go ahead and implement both of those classes. Let's just go ahead and implement car. So for that we'll do class car and then inherit from vehicle. And then I'll simply do a pass here, but it's actually showing me some errors. So I'll just import vehicle. Okay. Let me just copy this up and then paste it to truck. And I'll just simply rename this to a truck. Okay, that looks good to me. So now we have created classes for both car and truck, but let's go ahead and make sure that those changes are used in insurance calculator as well. So let's say we want to check if this vehicle is an instance of car. If so, we'll have some logic there. Some logic of calculating the insurance for that car, and if it's a truck, we'll calculate it in a different manner. So let me move the age calculation beforehand and then have if is instance of vehicle is an instance of car, then simply return. I'll have it to return 1000 if the age is greater than 5, else 500. Similarly, I'll have an elif statement here, checking for is instance of truck, and if so, we'll simply return 1500. Else, let's say 700. Okay, let me get rid of this. And we also need to import car from car. Oh, I think I'm having import here. No worries. So similarly, we'll have truck import truck. That looks good now. Now, once we have all the changes in insurance calculator as well, let's just go ahead and check our main method, and we'll have to make changes here. So let's say I have a car initialized as, I'll basically use this one. Simply copy and then paste here. I'll also have a truck. Oh, it looks like I haven't imported those. So let me just go ahead and import those. Car, import, car, and similarly for truck. Okay, looks good. And then I think I misspelled it. No, that's correct. Okay. So let's just go ahead and then initialize this as, let's say, Ford. And then Ford F-150 is the most famous one. So I'll do that. And 2015 edition. Okay. Let me get rid of this vehicle here. Okay. Now let's move on to use those in the insurance calculator. And insurance calculator, vehicle, and then we'll have two print statements for both of those. Let's just do that. In one, I'll pass on the car, and in the second one, I'll simply have the truck. Okay, that looks good. Let's just go ahead and run that. Oh, it looks like I haven't sliced this. Let's just change this to car. It should work perfectly. Okay, let me just clear this up so that it's visible. Okay, let's just run this again. Okay, so the car calculated is 1000 and this is 1500 and this looks correct. Let's just get rid of this one. and we are good to go. Now, after making those changes, we can say that we just broke the open-close principle. We had to introduce new features, in this case, car and truck as a new vehicle. And in order to do that, we just modified our insurance calculator class here. We didn't add new things or new classes, we modified our existing class. So we broke open-close principle. Let's say somebody comes up and says that we need 4 different new types of vehicles. We'll need to add more if-elif statements here, and that would become ugly. Now there are 2 things here. First thing is how to follow open-close principle and fix this code. And the second part is why do we even care about following open-close principle? What were the consequences? What are the consequences for it? So let's do the first thing here. That is fix this code to follow the open-close principle. And how will we do that? So for that, we'll have to go to the vehicle.python file here and then make some changes here and there. And here we'll have to import, let's say from ABC, import ABC and abstract method. We'll convert this class vehicle to an abstract class. I'll make the changes and then probably talk about why we are doing it. And I think this can go well. Okay, this looks good now. Now, why have we converted our vehicle class to abstract and added an abstract method here for calculate insurance cost? So, first off, we have added this calculate insurance cost method here so that all of the subclasses, car, truck, bus, we ensure that all of these classes have to implement the calculate insurance cost. Otherwise, we'll see runtime issues. Why runtime issues? Because if somebody comes up and then goes into car and forgets implementing this, then we'll see a runtime issue. Now, why have we converted our vehicle to abstract class? This is because we don't want anyone looking at this code base to use vehicle directly. Rather, we should have multiple subclasses like car and truck, which are subclasses from vehicle, and we instantiate both of those. So let's say if we go to main.python, we don't want anybody to come here and just instantiate vehicle. That doesn't make sense, right? Let me just save this. So that is why we have our vehicle class as abstract. So let's just go ahead in the car and truck classes and then use this. So how will we use this? So we'll go ahead and just define our get calculate. I think calculate insurance cost, that's correct. And we'll just make some changes here. We'll go ahead and copy paste from the insurance calculator. And this might change to self. And we'll also copy paste this logic from there. And I think we should be good to go. We'll just simply copy paste it to truck. And we should make a slight change. Just copy paste here. And we should be good to go for the car and truck. Now moving on to our insurance calculator, we'll simply get rid of all of this and we'll return vehicle.calculate insurance cost. That looks good. We'll also get rid of both of these imports as we do not need any of those. And let's just save this and move on to the main method. So here we have instantiated car and truck and we have different prints. Let me just copy this for the truck or basically autocomplete there. Let's just try to run this now. Okay, that looks good. Our car insurance cost, I think I should probably move it to truck insurance cost. Let's just run this again. Let me clear this first. And then run this. Okay, so the car insurance cost is correct and truck insurance cost is also looking good and both of those prints are also good. So that basically tells us how open-close principle works. We have changed our code in such a manner so that we have a vehicle abstract class and then multiple subclasses which have specific logic for calculating insurance cost. Also, we got rid of all of the logic that was inside this if-else statement inside the insurance calculator. Now, with this, we have understood what open-close principle is and how it works. Now, let's move on to the second part on what happens if we don't follow the open-close principle. So, if we go back here and look at what happens if we don't follow open-close principle, the first thing is adding new feature becomes chaotic. So for that, let's just take a look at our previous code. Let me just copy paste it here, all of this. So we had multiple if-else if statements here. So let's say you had more such classes like insurance calculator. There would be another class called as resale value calculator. So there would be another set of if-else statements like this. Whenever you create a new class, let's say bus or motorcycle, whatever, you'll have to first create that class. Let's say I go ahead and create a class called as bus.py. I'll have to make that class and then come back to all of these individual classes, let's say insurance calculator, resale value calculator, and add elif statements for them. Don't you think that's like too much? That's like very chaotic. And that is why we follow open-close principle and only make changes to the new class itself. Of course, this can't always be 100% of the time. It's not 100% accurate. But following this principle as much as possible keeps things organized. So that would be the first consequence. The second consequence would be modifying existing classes can introduce a lot of bugs. So let's just go into the example here. We had this code early on for the insurance calculator. Let's say I create another class for motorcycle. So for that, I'll go ahead and create a class here for motorcycle. And I'll have to come on to this class, insurance calculator, and add an elif statement. But what if I forget this part? I'll just simply add a class and then forget about making change here. In that case, we'll see error being thrown. So don't you think that's a bad design? So that is why we follow the open-close principle to not get into these ugly consequences. So once we have that, let's just look at some of the thumb rules that we can follow. Here I have added one of them, which is we should probably avoid these if-else statements. Like for example, in this one, where we are checking for instances of vehicle as car and truck. So avoid these if-else statement where you are checking if a vehicle is an instance of car or truck. Rather, have a base class and multiple subclasses which have their own unique behavior. So let me just get rid of this. And as you can see, we had a vehicle class and all of these car and truck are showing their unique behavior inside of these classes. That's what we want. So that's it for the open-close principle. I hope to see you in the next one where we'll discuss the Liskov Substitution Principle. Hello everyone. So in this video, we will be learning about the third solid principle, which is Liskov Substitution Principle. It is a very scary one. No, not really. It's not that scary, but very, very simple. So let's just get started with it. So what is the definition of Liskov Substitution Principle first of all? It says that any instance of a subclass should be substitutable for an instance of its base class. So simply put, the subclass should behave in such a fashion that is consistent with the base class. Well, I'm pretty sure you found that confusing, and I'm pretty sure you didn't get anything from it. So let me take a very simple example to demonstrate that before you guys run away from this video. So let's just go ahead and make some changes to our vehicle class here. We'll also have an abstract method. Let's call it refuel and then pass. Now we'll go on to copy this and implement in both of our car And we'll make some changes here. Let's say I want to print refueling the car with petrol. Similarly, I'll copy this and then paste it to our truck. Just paste it here and we'll change this to diesel. But wait, did I just break the open-close principle here? Looks like in the vehicle class, I added a new method called as refuel, and looks like we have broken the open-close principle. Well, not really. So this is because we are not modifying the internal code inside any of the pre-existing methods to add new features. Instead, we are adding a new method and that doesn't alter any existing functionality. So we are good. We are not breaking open-close principle here. Now let's say we want to add another class here. Let's say we want to have electric car, and then for that we'll have from vehicle, and then I'll implement the whole class here. Let's just get rid of all of this. I think we'll define the calculate insurance cost as, let's say I go ahead and use this logic here. I calculate the age as 2024 myself here, and let's just change these numbers to 2000 and 1000. Wonderful. Now similarly, let's go ahead and make changes to this refuel method here. Since electric cars do not have the refueling, they charge via electricity. What I'll do, I'll raise an exception here saying that electric cars cannot be refueled. Let's start with that. Now after that change, let's just move ahead to our main class and then make changes here. So first of all, I'd like to import the electric car from electric car. That looks correct. And then for this part, what I'm trying to do is have an electric car. Okay, that looks correct. Now I'll have a vehicles list which will contain all of these. That looks correct as well. Now I'll have a loop for vehicle in vehicles just to a refuel. So let's just go ahead and run this. Let me see. I think there is some issue here. Oh, it says electric cars cannot be refueled. Both of those, car and truck, I think those went well. I think refueling the car with petrol and refueling the car with diesel, that looks correct. But what about this, the electric car? I think that is showing an exception. Well, that was expected, right? So now we see a runtime exception here because our subclass in this case, electric car, is implementing some of the methods, but not all from vehicle. So it was implementing calculate insurance cost correctly, but not refuel. It was throwing an exception there, right? So we broke the Liskov Substitution Principle here. Electric car is not consistent with its base class, which is vehicle, and it should have a refuel method which doesn't throw exception, rather print something very similar to all the other classes like car, truck. So don't you think it's a very intuitive principle? Whenever writing a class, you should always be consistent with your parent or base class and implement all the methods in it, right? So it's very, very intuitive principle. So in general, let's say there were 10 methods in base class in this vehicle.py, and your new class only implements 8 of them. For 2 of them, it simply throws exception. That would again violate Liskov Substitution Principle. But now, one very natural question comes to everybody's mind is that we will run into these kinds of ugly situations very, very often, where we can't implement all of the methods from our base or parent class. So what could be done here? Well, for that, we will see how we can solve that using the I in solid principle, which is interface segregation principle. Not in this video, but the next one. So for now, let's just get rid of our electric car class itself. Let's just fix that. And in our main method, we'll have to make some changes. We'll have to remove this and also this part and this one. I think now it should probably run. Okay, so it looks correct now with diesel, the insurance cost and the printing. That looks correct. Now we all know that we should implement all the methods from its base or parent class. That's what we saw here. But there is one more thing to remember in Liskov Substitution Principle. We need to be consistent too. Well, wait. What does that being consistent mean? Didn't it mean that we need to implement all the methods? So let's just understand this using another example. So let's just go into our truck class and let's say we make some changes here. We say when we calculate the age, we'll add one more condition here. If age is greater than 20, let's say, we'll return none instead of a numerical. Now let's go ahead to our main method and try to run this. This looks good according to me. But what if I change some things here? Let's say I change this to 1990 or let's say 1980. And I also go ahead and add 100 to both of those and try to run this. Oops, looks like we are having some runtime issues here. So when we do that, we have changed the logic in such a fashion in truck that the age, if it's greater than 20, will return none. And we can't add none to 100. And that is where everything goes topsy-turvy. But that wasn't the case with car. We didn't make any such changes in that. All of the returns from this method are numerical. So there was no issue with that. Here again, we broke our Liskov substitution principle when we made our changes here. Here, we were returning none sometimes and sometimes numerical. But that wasn't the contract that was present in vehicle. This whole method was implemented in such a fashion that it would return numerical. That was being followed in car here, but not in truck. So that is what Liskov substitution principle says. We need to be consistent with our parent or base class. So let's just go ahead and get rid of this part here. And let's just try to run this again. And now it works perfectly. So let's just summarize what all we have learned today. The first point is, in order to follow Liskov substitution principle, each class needs to implement all the methods from its base or parent class, that is both of those without any exceptions. The second thing is, each method implementation should be consistent with the base or parent class. In our truck case, we saw that we were returning none sometimes numerical values. That was inconsistent with what vehicle had. So in order to follow Liskov substitution principle, we don't need both of those. We need to implement all of the methods from its base class, and we also need to implement in such a fashion that it's consistent. Now we can say that we have understood Liskov substitution principle. But again, we have the same question again and again. Why are we even learning this? What happens if we don't follow this Liskov substitution principle? So let's just go ahead and understand that here. So what happens if we don't follow Liskov substitution principle? Well, we have already seen the consequences here. So if we don't follow this principle and then create subclasses, like let's say electric car, or we made changes to the truck which were inconsistent with the parent class, that could lead to unexpected runtime issues. That's what we have seen here in the case of truck and case of the electric car here. So we'll see errors or incorrect results. So what is the summary? What should we as developers remember? So, well, there are two thumb rules here or pointers that you should understand, which are basically the Liskov substitution principle. So the first thing you need to remember is that whenever you create a new class, make sure to implement all the methods from its parent or base class. Very intuitive, right? The second one is whenever you are creating a new class, make sure to have it consistent with the base parent class, especially the return value. That's what we saw in the truck case. So that's it for this video. Hope to see you in the next one where we'll be learning about interface segregation. Pretty exciting, right? So see you in the next one. Hello everyone. So in today's video, we'll learn about interface segregation principle. This is the fourth principle from the solid and it's a very exciting one. So let's just get started with it. So let's just understand it with the definition here. So what does the definition say here? So instead of having one large all-purpose interface, we need to break the interface into smaller, more specific interfaces. That is why the name interface segregation principle. But why do we do so? This is because we want each class or the subclass to only have methods that are relevant to them. A class should only have to implement methods that it actually uses. The last part might be confusing to you, so let me break it down using the examples. Now, before we move on, I want to point out one important detail here, which is that the most common way to create interfaces in Python is by using abstract base classes provided in the ABC module. We have seen that in our vehicle class, we are taking ABC module and then creating an abstract base class here, abstract class. Now, interestingly, this ABC stands for the same. It stands for abstract base class. Now, ABC allows you to define methods that must be implemented by any of its subclass. So let's say I have a method here, calculate insurance cost. Now, this should be implemented by all of its vehicle subclasses. So if I go to car, we are implementing calculate insurance cost here as well, and similarly for truck too. But let's say we create a subclass which doesn't implement this. Then in that case, it will raise error. Now, in order to explain interface segregation, let's just add a few methods here. Let's just add a refuel method. And then for this, I don't need any implementation. I'll just do a pass. And I'll also add a method called as recharge. Okay, and that looks correct. Now we'll have to go inside car and truck and implement both of these. So let's just go ahead and do that. In car, we'll come and say refueling car with, let's say, petrol. That looks correct. And similarly, we'll also have a method for recharge. And since the car doesn't have, it's not an electric car, so it doesn't recharge. It only refuels. It uses petrol. So for that case, I'll simply raise an not implemented error and say that cars don't need to be recharged. That looks correct. Okay. And similarly, I'll copy both of those and paste it inside truck. And let's replace this with truck. And this should be diesel. And this replaced by trucks. That looks correct now. Let's now go ahead and also create a class. Let's say I want to create a class called as electric car. And let's just say from vehicle, we import vehicle and then class electric car. Let me just get rid of this. And then we'll have to implement something regarding insurance cost. So I'll have this logic here. I'll calculate the age and then return 2000 if age is greater than 5. Else I'll just simply return 1000. And for refuel, now for electric cars, we don't need any kind of refueling. It recharges. So I'll raise a not implemented error and say electric cars don't need to be refueled. But we'll need to have a recharge method and call it, let's say, print recharging electric car. That looks correct. Now let's go ahead and make changes to our main method. So I'll go ahead and simply do from electric car import electric car, and then I'll initialize something here. So let's say electric car. Okay, that looks correct now. So I'll try to use this. Let's say I want to have car dot refuel and truck dot refuel. I think I'll get rid of this for now, and we can have for electric car, I'll simply do electric car dot recharge rather than refuel. Let me go ahead and just run it, and it looks correct. There was no error thrown, and it was able to refuel it. So that looks correct. But what if I run this? Let's say electric car dot, and then I do a refuel instead of a recharge. Let me just run this. Oops, I see an issue here. It says not implemented error. Electric cars don't need to be refueled. It's because we haven't implemented it. It doesn't make sense to have a refuel method inside the electric car. Similarly, if we get rid of this and then just simply run car dot recharge and try to run this, it again throws an error. Says that not implemented error, cars don't need to be recharged. That makes sense. This is again because for cars, having a recharge method there inside it and saying that it's not implemented, this doesn't make sense at all. So what should we do? We should go ahead and break down our vehicle into different interfaces. We'll break down this vehicle into different interfaces which are smaller in size and more granular. Here we are trying to force all of these classes, car, truck or electric car, to implement all of the methods that is present in vehicle, which shouldn't be the case. We should have smaller interfaces from which all of these car, truck and electric cars can take those necessary methods there. So let's now try to fix this. How will we fix it? Let me go ahead and create a new file. Let's call it, let me call it fuelable. And in here we can have all the code regarding the refuel part for that vehicle. So let me go ahead and just do from ABC import ABC and abstract method, and let's call it this abstract method and have a refuel here. Now, very similarly, we'll have a class or abstract class for rechargeable. So let me go ahead and do that. So I'll create a new file here. Let me first copy all of this and then simply create a file. Let's call it rechargeable.py. That looks correct. So let me change this to rechargeable, and I should probably change it to recharge. Looks like I have made some naming issue here. I should probably rename it to a smaller case viewable. Let me try it one more time. Okay, so that looks correct now. Now let's go ahead and get rid of all of these methods from here because we already have it in viewable and rechargeable. And for these classes car and truck, what I'll do is I'll also have a viewable because it's a viewable. And I'll also need to import viewable from viewable. That makes sense. And I also need to get rid of recharge because that doesn't make sense. For truck, I'll do the same. I'll go ahead and do from viewable import viewable and change this to viewable and get rid of this again. And that looks good now. Similarly, for electric car, I'll need to import from not fuelable, there should be rechargeable. I should import rechargeable, and then I should have rechargeable, and I'll get rid of refuel because electric cars don't get refueled, they get recharged. So that looks correct now. Now, this way, using interface segregation, we segregated our earlier vehicle class or abstract class interface to multiple abstract classes or interfaces. And now, if we make changes to our main method, let's say I want to have electric car dot recharge and car dot refuel, that would totally work perfectly. So that looks good now. And if we even, because we won't be going into a situation where we'll go ahead and do car dot recharge because it wouldn't pop up also. That method doesn't exist inside car. So we won't get into any kind of runtime issues. That's what interface segregation does. So just to summarize what we did here, we had an abstract class called as vehicle or an interface called as vehicle. It had multiple methods here for refuel and recharge. And for car and electric car, all of those had to implement those. It was a necessity for both of those subclasses to implement both of those. And that was throwing error in our main method when we were trying to run all of that. And that is why we segregated our vehicles method into multiple other interfaces called as fuelable, rechargeable, so that it's convenient for car, truck, or electric car to take relevant methods from them. And that is why we have a rechargeable here and fuelable here. And even if you see, some of the methods from vehicle are taken for all of these classes, car, truck, and electric car. The vehicle part is common there. So since we are taking it from vehicle, this needs to be implemented. Now we can say that we have understood interface segregation properly. But again, a curiosity kicks in my mind. What happens if I don't follow interface segregation? Let's go ahead and understand that. So what happens if we don't follow it? First thing is, classes may be forced to implement methods they don't need, leading to irrelevant code or not implemented error placeholders. That's what we saw, right? These classes like car, electric car, these all classes were forced to have those methods which were irrelevant to them. And in that case, we just simply added a not implemented error or raised the not implemented error. And that led to unexpected runtime errors. By mistake, somebody can come in and write a code which would basically run those methods which are not implemented. And that would be chaotic. The second consequence that we see if we do not follow interface segregation principle is that adding new features or modifying functionality becomes very hard. Why are we saying so? Because if you see, if I had the vehicle class here, let's say I have another method called as abstract method. Let's call it defined as load cargo, which is only relevant to, let's say, the truck and not relevant to car or electric car. So in that case, what we did that we have to go into each and every class, car, truck, electric car, and we have to implement this method. Don't you think that's a bad design? And that is why we use interface segregation to segregate into very relevant small abstract class or interfaces. Hope that makes sense now. Now, after this discussion, what are some thumb rules that you should remember and take away from this video? I would say that do not cram all the functionalities into a single interface. Instead, split them into smaller interfaces however you can. So, I just rephrased the whole interface segregation principle to you in a different language. but bear with me. So whenever you are in a state where you are having methods which have not implemented error, you get into a situation where you have to do a not implemented error for any of the methods, then you should probably think about this interface segregation principle and break into smaller interfaces. So that's the first thing here. The second thing is when different classes share but not all the behaviors, like in our case, we had car, where car is sharing some methods from vehicle and some from fuelable. Similarly, if we see for our electric car, it's taking from vehicle and rechargeable. So that's what it's saying. So when different classes share some but not all behaviors, considered using composition with smaller interfaces instead of having a broad interface like our previous vehicle class where we had all the methods there. Hope that makes sense now. Well, that's it for this video. Hope you guys understood the interface segregation principle. It is, in my means, the easiest of the lot, easiest from those solid principles. And in the next video, we'll learn about dependency inversion. So see you there. Hello everyone. So in today's video, we'll learn about dependency inversion principle. The name itself seems to be very scary. And let me be very honest with you here. Like, I wasn't able to understand it for quite some time. I watched many videos, read from multiple books, and practiced a bit. And then only I got what it means and why do we even use it. So let me take this opportunity to explain it to you. So as always, let's start with the definition. What does dependency inversion principle say? It says all components or classes should depend on abstractions and not on concrete classes. This makes the code much more flexible and decoupled. Now, if you have dependencies in a class, it better be an abstract class. Otherwise, you will get into trouble. If you're wondering what dependencies are, why should I depend on only abstract classes and all those questions, just give me 5 to 7 minutes and I'll explain you all these things using an example. So let me take a moment to go over this repository which has numerous classes here. We have a vehicle class or an abstract class which has some initialization and a method or an abstract method called as insurance, calculate insurance cost. We have other abstract classes such as fuelable, which has only one method refuel, and rechargeable, which only has one abstract method called as recharge. And we have numerous classes like car, truck, electric car, which implement all of these methods, taking from vehicle, fuelable for the car. Similarly, for truck, we have vehicle and fuelable, and we are implementing calculate insurance cost and refuel. And very similarly, we can look at electric car. And we have the insurance calculator class here, which just has calculate vehicle insurance. And we are testing all of this in our main here. So let me just run this once to see if everything is working perfectly. Okay, it looks to be correct. I can see no errors here. So let's just move on now. Now, after implementing all of those things and checking that everything works correctly, let's go ahead and create one more class. Let me move it here. Let me call a new file. Let's call it break inspection tool, or rather, I should probably have break inspection tool. That looks correct. And for that, I'll just simply take from vehicle. I think I missed on the spelling there. Let's have that. And let's implement this class, break inspection tool. I don't need initialization. I just need one method here, which is for performing a break inspection. Let's see. Okay, that looks correct. And for this, I'll have, let's say, perform break inspection on let's say, a vehicle, which is vehicle.make and vehicle.model, and We'll keep it this way and no need to format it. Oh, I think I should probably format it. Okay. And similarly, we'll also have another class called as maintenance service. So let's just go ahead and create one. So I'll say that as maintenance service, and I'll have taking it from break. That is correct. Import brake inspection from vehicle. Import vehicle. That looks correct. And let's say class maintenance service, and then I'll have some kind of initialization, and let's call it self.break. That looks correct. And similarly, I'll have one more method here. Let's call it service vehicle and self.break inspection tool. I'll rather talk about not having brake inspection tool, but self.tool, and I'll use that here and perform brake inspection. Yeah, that looks correct to me now. Now, if I go ahead into main and try to test it out, let me just go ahead and add, and before that, I'll need to import it first from the maintenance service, import maintenance service. That looks correct. Now let me add a code here for the maintenance service, and then I'll simply call service, or let's call this maintenance service as service, and then I'll do service dot service vehicle as car. Okay. So let me just go ahead and run this. Let me move it here so that it's in the end and it's visible. So let me go ahead and run this. Okay, performing brake inspection on Toyota Camry. That looks correct. Now, until now, everything looks correct. But if you see our maintenance service is directly dependent on brake inspection tool. The dependency here for maintenance service is brake inspection tool. So let's say somebody comes up and suggests, instead of having brake inspection tool, let's have tire rotation tool. So I'll go ahead and let's say I do it tire rotation tool. So in order to do that, I'll have to make changes here. I'll also have to make some changes here. But that doesn't sound very bad, right? But here, if you notice, we are breaking open-close principle. How so? We are modifying our existing class's method and not adding a new class and using that to add a new feature. So we are breaking open-close principle. So what are the consequences for it? So all the classes where this maintenance service is used and service vehicle is called, we will have to go into each of those classes and check if everything is working expected or not. So let me rephrase it. Let's say I have a class which uses maintenance service. Or let's say there are 10 classes where maintenance service is used. And in all those 10 classes, I am calling maintenance class dot service vehicle. In all those classes, I'll have to go ahead and check if this new definition with car rotation tool is making sense or not. That would be a very big hassle, because if you see, this is a very small repository. If we have a very huge code base, that would be very problematic. So now we have run into a situation. So how to fix this? Let's go to our definition of dependency inversion. All components should depend on abstractions and not on concrete classes. So here our maintenance service was dependent on brake inspection tool, which is a concrete class and not an abstract class. So we'll fix that. So let's just go ahead and create one more abstract class. Let's just go ahead and call it maintenance tool. Okay, so from this, what I'll try to do here is I'll create it as an abstract class. import ABC, and from vehicle, I will have vehicle. Now, let me define this class, and I'll have an abstract method of perform, let's say, maintenance. That should do. Here, if you see, I have created a generic method called as perform maintenance, and it is taking an input as vehicle. Now, what I'll do here is that I'll use this abstract class inside brake inspection tool. I'll go ahead and import from maintenance service, import maintenance service, and then I'll basically inherit from that. That looks correct. And I'll need to change this to perform maintenance. That looks correct. And it is taking vehicle as input. And I can have any print statement here. I can say perform brake inspection on vehicle.make vehicle.model. So that looks correct now. Now, once we have that abstract class ready and also make changes into this brake inspection tool, now we can go ahead inside the maintenance service and use that abstract class, that is maintenance tool. So let's just go ahead and remove this from maintenance tool, import not brake inspection tool, but rather maintenance tool. That looks correct. And now let's use this maintenance tool in place of brake inspection tool. So let me just get rid of this, and we'll pass on this as tool and maintenance tool, and then we'll use it. Why am I using that as input or in the initialization for maintenance service? I'll talk in just a bit. So let me just make changes to this, and instead of performing brake inspection, I'll need to change this to perform maintenance. That's correct now. So after that change, let's go ahead and make changes to our main method and test it out. So here we have the main. I'll probably need to import from brake inspection tool, import brake inspection tool, and I'll need to pass it on to the maintenance service. So I'll do the brake inspection tool, and let me just go ahead and run this. Oops, I see an error here. It's in brake inspection tool, and I think I know it. I think we are taking inheritance from maintenance service instead of maintenance tool. I'll just change that. And let me just copy this here. And that should probably fix it. So let me just go ahead and run this again. And everything looks perfect again. Performing brake inspection on Toyota Camry. Now let's go ahead and talk about why we have any kind of tool like brake inspection tool here as a parameter in maintenance service. Like as you can see, we have a tool, maintenance tool as a parameter. Why did we even choose this kind of design? This is mainly because let's say we have another tool, or we want to change this tool here from brake inspection tool to, let's say, tire rotation tool. So I can simply go ahead and then replace this. Let's say I'll do tire rotation tool. And obviously I'll create a class for that, very similar to brake inspection tool. But you see the convenience here. We just have to make changes here and good to go. We do not have to go inside the maintenance service to make any kind of changes there. If we would have to make changes to an existing class and a method, that would break open-close principle, and we do not want that. So that is why we have the design of passing in the brake inspection tool or any kind of tool inside the maintenance service. This is also called as dependency injection, where we are injecting a tool or a tool, brake inspection tool or anything inside maintenance service. Now let's talk about what happens if we do not follow the dependency inversion principle. So let's just go ahead and understand that. So the first thing, what happens if we don't follow the dependency inversion? Let me just go ahead and change this. Yeah, what happens? So we will break the open-close principle as we saw, we will need to modify the existing methods. And if we do that, there's a high chance you might introduce bugs when modifying existing classes. So as you could see in the previous implementation, if we made changes to here, if we made any changes to our maintenance service class, our previous one, then we would have to go inside each of the other classes which uses maintenance service and check if the new implementation made sense or not. Like let's say we had, earlier we didn't had this, we had our tool as brake inspection tool here. So let's say if I change it to tire rotation tool, I'll have to go inside each of the classes which use maintenance service and then check if this new implementation with the tire rotation service is making sense to that or not. Yes. So hope that makes sense now. So that's what happens if we don't follow dependency inversion principle. But what are some thumb rules that you should remember at the end of this lecture? The first thing is always have abstract classes or interfaces as dependencies. Try not to have dependencies on concrete classes. Here you can see that we have dependencies on maintenance tool. The maintenance service has dependency on maintenance tool here. And maintenance tool is an abstract class, not a concrete implementation. So you want such a design which depends on such a class where it depends on other abstract classes or interfaces. The second one is always try to pass dependencies into the class when initializing. So as you can see, we are passing in the brake inspection tool to maintenance service. That kind of design we want, because in the case where you want to change the tool, let's say I want to change the brake inspection tool to tire rotation, I can freely do that. So we have some kind of flexibility. So those are the two thumb rules that you should remember at the end of this lecture.